This video is going to show how to create and simulate a non-ideal resistor model with the model editor in OrCAD PSpice. Creating a non-ideal resistor will allow you to incorporate parasitic inductance and shunt capacitance to create a realistic simulation. Open the provided design in OrCAD PSpice Designer. First, let's simulate an ideal resistor model. Select PSpice, New Simulation Profile from the menu. Name the profile AC Trans and click Create. Set the run-to time to 60 milliseconds. Leave the other settings as the defaults and click OK. This will create a transient simulation with a duration of 60 milliseconds. Select the Voltage Level Marker button from the toolbar. Click to place a probe on the AC1 net. Select the Current Marker button from the toolbar. Click to place a probe on the pin of R2 connected to AC1. This will automatically generate the waveforms for the voltage and current at the probe points when the simulation is performed. Right-click and select End Mode. Select PSpice, Run from the menu. View the simulation results. The voltage and current of the ideal resistor are in phase, as expected. Next, let's replace the ideal resistor model with a non-ideal resistor model. Back in the schematic, select resistor R2 and press Delete on the keyboard. Select Place, Component from the menu. The Unified CIS tab opens. Expand PSpice from the Categories list to view the default PSpice models included with the software. Select Passive. Enter AWB resistor into the search field and click the Search button. Right-click the AWB resistor component and select Place. Click to place the resistor in the empty space. Right-click and select End Mode. This model includes default inductive and capacitive properties. Let's see the effects of these properties through simulation. Select PSpice, Run from the menu. The current has decreased and now leads the voltage. The resistor has inductive and capacitive properties, which are causing the phase shift. Let's modify the properties of the non-ideal resistor model to reflect the actual component we'll be using in our design. Back in the schematic, right-click the resistor and select Edit PSpice Model. The PSpice Model Editor opens with a table of simulation parameters. Set the resistance to 4.7, the ESL to 10 millihenries, and the capacitance to 10 picofarads. Select File, Save from the menu, and close the model editor. Since the model was modified, it needs to be associated again with the resistor. Right-click the resistor and select Associate PSpice Model. A prompt will appear saying that the design must be saved prior to association. Click Yes. Another prompt will appear saying that the current PSpice model will be overwritten. Click Yes. The Associate PSpice Model window opens. Click Browse to browse for the library. Browse to the location of the step-down trans PSpice files folder provided in the materials. Select the file stepdowntrans.lib and click OK. Confirm that symbol pins B and A match with model terminals B and A in the model mapping table. The model text containing the SPICE code can also be previewed in this window. Click Update Selected to update the resistor. An info message will appear indicating that the model was attached successfully. Click OK. Let's see how the changes to the inductive and capacitive properties affect the simulation. Select PSpice, Run from the menu. View the results. The current now lags the voltage due to the increased inductive reactance and peaks closer to that of the ideal resistor due to the decreased resistance. For more tutorials, visit us at resources.ema-eda.com and don't forget to like and subscribe to our YouTube channel.